solving systems of linear equations using substitution. Yesterday we talked about when you're graphing systems of linear equations, how do you tell what the solution is when you graph two lines?
Word process.
The
Oh,
same
you
word
get
process.
it.
So, what is the solution? A point. And so how do you label a point? It has two numbers, right?
Yeah, number point.
It has coordinates. So it has an x coordinate and a y coordinate.
Yeah.
Okay. Sometimes you actually have more than that, more than just the x, y. Sometimes there's an x, y, z. We'll talk about that later, but I'll deal with that right now. So there's two numbers. So we're trying to find the x value and we're trying to find the y value. If they cross and they don't cross at a perfect little number where two of the lines meet, from the graph you can't always tell. They're like in between two numbers. And so that's when we have to come up with some other options. And in this case we're going to deal with substitution. So I'm going to give us a couple of equations that I want to solve the system. 3x plus 4y equals 12. And 2x plus y equals 10. Now, I'm going to tell you which you can believe me or not. If you don't believe me, that's fine. You can just go and do it yourself. But I will tell you that if you graph these, they're not going to intersect on any whole numbers. They're going to be on decimals and fractions. And so being able to tell from a graph, you would not be able to. Okay? What the solution is. My phone's over there. Alright. So what we have to do is use something called substitution. So what's the word substitution mean?
Replace.
Swap it out, replace. What are you replacing it with?
Something else.
Preferably something equal, right? So if you're in a football game and you take out a running back, what are you probably going to put in as a substitute?
Running back.
Normally a running back.
Right.
Okay? So about in a basketball game, you take out a post player, you normally put back in a post player. Now, I had one student today tell me, I can play whichever position. I was like, well, when you go in for a guard, you're a guard. It was like that. I said, well, when you go in for a guard, you're a guard going in for a guard. When you go in for a post, you're a post going in for a post. So you're replacing something equal. It would be great if in sports we could replace it with something that's completely equal, like same ability, you don't lose anything. You're just giving one person a rest to put in another person that's the same. But that's not the case. But in math, they have to be equal things that you're substituting.
Right.
You can't just say, oh, there's a 3, I want to plug that in for x because 3 is a lot easier than x.
Right.
You can't do that unless that's what x equals. Okay? So what we need when we do substitution is I need to solve one of the equations for one of the variables. And so you get to choose which variable in which equation you solve for. So we need to try to figure out one that's the easiest to solve. So looking up at those two equations, which variable and in which equation do you think is the easiest to solve for?
The third one.
The second one, the first one? Which variable?
You have to get Y on the other side, both of them.
The easiest variable to solve for is y in the second equation. Why is the y the easiest one to solve for? Because it doesn't have a coefficient. Other than its coefficient is 1. Okay? And so that's what I'm going to do. I'm going to solve for y in that second equation because I need to get y by itself. I need a variable by itself. So to do that, I need to get rid of that 2x, which means I got to subtract the 2x from both sides. So I have y equals 10 minus 2x. So, what does y equal?
10 minus 2x.
So I know something that I can replace y with. I can replace y with the expression 10 minus 2x. And
Y
on top-
and 8x.
Do I now?
Why then 8x?
Because you can't combine a number and a variable when you're adding and subtracting. So the 10 doesn't have an x with it,
Mm-hmm.
so I can't combine the 10 and the 2. So you gotta have the same variable. So what I'm going to do is I'm going to substitute in that 10 minus 2x for y in that first equation. Okay, I solved for y in the second equation, so I'm going to substitute back in for y in the first equation.
Oh, that's together. I thought it was separate.
And so I'm going to rewrite that first equation as 3x plus 4, and then where y is, I'm going to substitute in 10 minus 2x. And since that said 4y, that's 4 times y, and so I put what y was going to be in the parentheses, so it's still 4 times y. Now, that becomes a little bit uglier equation, but what is the benefit of doing this?
Make it easy.
Well, up here I had x and y. Now I just have x's. Okay. So at this point, I can solve for x and actually get a value. I can get a numerical value at this point. Okay. So we are going to do that. So first step is to distribute the 4, so we get rid of those parentheses. So 3x plus 4 times 10 is 40. And then 4 times a minus 2x is a minus 8x equals 12. So that step, all I did was distribute the 4. So what was inside the parentheses?
Combine all right terms.
Yes. Next step will be combining my terms. So what are our like terms in this next step?
3 and negative 8.
Yeah, 3x and negative 8x. So 3x minus 8x is negative 5x. Keep my plus 40 and I keep my equals 12. Okay, now this becomes a two-step equation that we did a lot of here in the first semester. Okay, so we need to move that 40 to the other side by subtracting it from the 40 and from the 12. So that's negative 5x equals negative 28. And y'all, I don't necessarily expect y'all to know all of these subtractions and divisions and stuff in your head. That's why you have calculators. So if you need that, use that. Okay, and then the last step here is to divide both sides by that negative 5. So that x is now by itself, and my answer is 5.6. So x equals 5.6. As I said earlier, these two lines are going to cross somewhere in the middle of two numbers. It won't be at a whole number. 5.6 would be difficult to find on a graph. Okay, so yesterday when we found a solution, what did we have to find? We found the point of intersection which had both an x and a y, right? What have we found at this point? Just the x. Now we found a value for x. Now we know an expression for y, that's 10 minus 2x, but we don't know what y is. So what we're going to do now is take our value we just found for x, 5.6, and we're going to plug it into that expression so we can find out what y is. So y equals 10 minus 2 times 5.6. So using the math, that's 10 minus 11.2. So y equals negative 1.2. So my solution is always x comma y. So 5.6 comma negative 1.2. What is
I got a lot of questions, man. I'm gonna start.
Let me kind of explain the rest of today very quickly, and so you'll kind of see where I'm going with this. We're going to do one more problem dealing with substitution, and then we're going to do two problems dealing with the other method called elimination. And then tomorrow we're going to deal with inequalities.
Not gonna get you down, Pat, first.
Well, the problem with that is Friday we're just doing a pre-test. I'm not fully teaching this right now. It's just giving you an idea. And then if we need to, which we probably will, we will do a lot deeper detail of teaching over the next couple of weeks. Okay. All right. So let's do another one and try to see if we can, y'all can kind of guide me a little bit more on this one. I know I already know it, but if you guide me, that lets me know you know. Here's the next one. So if you want to go and write it down, you can, and then I'll have y'all start helping me work through this.
Subtract x from both sides. Both sides.
Alright, so let's start with this question. Which variable is the easiest to solve for?
The second.
The second equation, for sure.
Yep.
Doesn't matter which variable,
No.
No.
because they're both just as easy.
Even normal.
Sure you got that? You stand at your lap a really long time. And so let's solve for x in the second equation.
There you go.
How do I do that?
I subtract x from both sides.
Well, if I'm solving for x, I'm going to subtract the other variable.
Sure what?
So I'll subtract y from both sides. That'll leave x equals negative 12 minus 1.
Why do a different time?
What do I do different?
So it's gonna take back there. You gotta do
Um,
both of them so it's a different
well-
part.
It doesn't matter which one you choose. You're just trying to find the one that's easiest. So I just wanted to show you, you don't have to solve for y. It can be x. Just solve for the easiest one to solve for. In this case, it would have been easy either way. They would have been the same process. But I just did the x this time since we did the y one
So you're gonna put that in the place of the x.
in that first equation. Yep. So once I know what x is equal to, now I can take that value, negative 12 minus y, and plug it in for x in that first equation. So that's 2 times negative 12 minus y minus 3y equals 6.
And you multiply everything.
Yeah, the next step would be to distribute that to. So if I distribute the 2, that becomes 2 times negative 12 is negative 24. 2 times the negative y is a minus 2y. So I have the minus 3y, and I still have the equals 6. Yes. So my like terms this time are the negative 2y minus 3y. So I have negative 24. Add those together, I get negative 5y equals 6. Then to get the y by itself, I need to add 24 to both sides. So negative 5y equals 30. And then lastly, divide by negative 5. Y equals negative 6.
I think that'd be easier.
Do what now?
The other one would be resolved from this.
I would say for most of my students, they would have to use the calculator for both of them, so it wouldn't matter. Decimals or whole numbers, the answers are just answers. Alright, so I found y, and what I need to do with that? Plug it back in, 4y up in this expression that's already solved for x. So, and negative 6 there. So x equals negative 12 minus a negative 6. And don't forget to put the minus and the negative with that. Because it's a minus y and then y is a negative, so you have to have the minus and the negative. And then when I add those together, negative 12 minus a negative 6 is negative 6. So my solution this time is negative 6, negative 6. So solving that system gives the solution negative 6, negative 6. So this one would have been one where you could have figured it out from a graph. Right. You okay with this one? Alright, so that's solving using substitution. So the next method we're going to use is called elimination. And so what does it mean to eliminate?
Delete, take away.
Delete, take away, get rid of. Alright, so if we are using the elimination method, we want to eliminate a variable. So we'll talk about how to do that as I get this written up here. 4x plus 2y equals 9. And negative 4x plus 3y equals 16. Okay. No. The ending you'll do kind of similar, but starting up. Let's kind of go through this one. We'll try to do a little bit quicker, just so we make sure we get through it, and the next one preferably. We're going to have a lot of time left. So, to eliminate, what we need is on one of the two variables, we need to have the same coefficient, but they'll be opposite. So like on the x this time, I have a positive 4 and I have a negative 4. That's what I'm trying to look for. Okay, I want one coefficient to have opposite or one variable to have opposite coefficients. Okay? And so that's what we have right here with 4x and negative 4x. And the reason why is because I'm going to add these two equations together, and when I do that, I want to eliminate one of the variables. Because what happens when you add 4x and negative 4x? You get 0, which eliminates the x completely. Once I do that, I can then solve for y. Makes it pretty simple. So, since these already have an opposite, I'm just going to add these together. 4x plus a negative 4x is nothing. 2y plus 3y is 5y. And 9 plus 16 is 25. So 5y equals 25. How do I solve for y now? Get rid of that 5, so I need to divide by 5, so y equals 5. Because 25 divided by 5 is 5. Okay. Again, I now need to take that and plug it back into one of these equations. So 4x plus 2 times 5 equals 9. All I do is replace that y with the 5. No, it's just y equals 5, so you have to plug it back in for the y. It doesn't say x equals 5. So it has to be equal. Okay, so now if I finish solving this one, that's 4x plus 10 equals 9. Next step, subtract 10 from both sides, so 4x equals negative 1. And then divide both sides by 4, so x equals negative 1/4. So my solution is negative 1/4, 5. And y'all, if you divided that out at negative 0.25, that would also be okay instead of the negative 1/4. That's still the correct answer. Look at this one real quick and tell me what's different about it. Because I'm still trying to solve using elimination.
Don't either one have x.
Neither one have that opposite x or coefficient that I need. Okay, so when that happens, you can still use elimination. You just have to create. You have to manipulate a little bit to where one of them they do have a opposite coefficient. So what you do, look at the one that has the easiest numbers to work with. 2 and 3 is easier to work with than 7 and 5, just for size. And so what you do is you find a number they'll both go into. So 6, 2 and 3 will both go into 6. So what do I need to multiply 2 by to get 6? 3. I'm going to multiply that whole equation by that 3. Okay? Now if I multiply this bottom one by 2, that'll give me 6. But what do I want? I don't want positive 6, I want what?
Negative 6.
Negative 6, I want the opposite. So to get a negative 6, I'm going to multiply by negative 2.
Look at what trustee being able to odd equations.
Yes.
So the variables don't have to match, they have to be negative.
No, they are going to have to match, because what we're about to do is distribute, and it's going to be a 6x, that's going to be a negative 6x. So we just have to create the match. Okay? So when I distribute, 3 times 2x is 6x, 3 times 7y is 21y, 3 times 4 is 12. And on this next one, negative 2 times 3x is negative 6x, negative 2 times 5y is a minus 10y, and negative 2 times negative 5 is a positive 10.
You're going too fast. Slow down.
I can't slow down too much, because then we'll run out of time. Yeah, all I did was distribute the two numbers on the outside. Okay. Now if I add the two equations together, the x's are now gone, because 6x plus a negative 6x is 0. 21 plus a negative 10 is 11y, and 12 plus 10 is 22. So in this case, y equals 2. So I divide both sides by that 11.
Now plug 2 in for either equation.
2 in for y in whichever equation you want to do. So I will plug it in for that first one. So 2x plus 7 times 2 equals 4. 7 times 2 is 14. Subtract 14 from both sides, so 2x equals negative 10. Divide by 2 and you get x equals negative 5. So your solution is negative 5, positive 2.
Your time with this one?
Yes. We have 2 minutes left.
You got no longer with it?
Yes.
You got 2?
Do what?
2 minutes?
Yes. Alright, questions on that? You will have a little bit of time to ask some more questions tomorrow over it. Again, I'm not teaching it right now so that you have it mastered. I wanted to give you a heads up on what's on the pretest so that you're not going into it blind. And then from there, we'll see how deeply we need to get into it. We'll probably get into it pretty deep. Stop this.